Greetings everyone, this is Mr. Mullen. In this podcast I'm going to be talking about solutions. This is an intro into solutions, and before we get into what a solution is and what is the process of making a solution, also known as solvation, I want to talk a little bit about something you already know, I'm sure a whole lot about, and that is mixtures. So we can categorize mixtures, and I know you know these two types of mixtures, into two different types, and the two different types of mixtures are, of course, homogeneous and heterogeneous. So we have our two different types of mixtures. Okay, a mixture. Remember now, we're not talking about pure substances, we're talking about a mixture, two or more elements or compounds that are not bound together, that are mixed together. So homogeneous mixtures have another name in chemistry, and they are also known as solutions. Homogeneous mixture solutions. The word homogeneous means same throughout. Okay, homo means same, geneous means throughout. So homogeneous literally means that your mixture is the same throughout. Same throughout. Another way to think about a homogeneous mixture is that it has uniform composition. So an example I like to think of a homogeneous mixture, maybe when you were a kid, or maybe you still have some of this. They have this children's drink that you can mix up with a lot of sugar. It's called Kool-Aid. And when you make Kool-Aid and you mix it up well, you'll notice that the color of the Kool-Aid is the same throughout. The taste of the Kool-Aid is the same throughout. Uniform composition. Okay, homogeneous mixtures. Each part of that mixture has essentially the same composition or ratio of mixed items. And then we have heterogeneous mixtures, also known as, we have a fancy physics word for heterogeneous mixture, and it is a suspension. Also known as suspensions. Heterogeneous, the word homo means same, hetero means different. Heterogeneous solutions are different throughout. Different throughout. In other words, there's a non-uniform composition. So when I was a kid, they had these cereal called Lucky Charms, and they still have them. So when I look at a box of Lucky Charms, what you'll notice is that what you really want, the marshmallows, they tend to be all sorted. If I look in the package, all those marshmallows float to the top, and you have a really good cereal in the beginning, but then you get to the bottom, and you notice that all of the stuff that you don't want is on the bottom with a couple marshmallows. And so as this box settles over time, these Lucky Charms are no longer mixed in a uniform way, and they become a suspension. The marshmallows become suspended over top of, and there's distinct boundaries. There's a distinct difference in phases. And so heterogeneous mixture. So we're going to talk the next unit very specifically about solutions. Okay, solutions. So what is, we're going to talk about first the process of making a solution is called solvation. What is solvation? Okay, you're not going to find this definition in a textbook, but I think that this will be helpful. So, in the process of solvation, we're going to talk about a bunch of words here, and then we're going to try to break them down. In solvation, soluble, solutes, dissolve, in solvents, to make, solutions. So let's talk about this. In solvation, soluble solutes dissolve in solvents to make solutions. So we need to break down these words. So in solvation, we're talking about the process of making a solution. Okay. Process of making solutions. Soluble. What does it mean, soluble? Okay, you think about putting sugar in water and we say that that's soluble. Soluble just means it is able to be dissolved. Okay, able to be dissolved. Alright, we have solutes here. So if something is able to be dissolved, the solute is the substance that is dissolved. And it's going to be the substance that is dissolved by your solvent. So if I'm making some sugar, I'm making some Kool-Aid, the Kool-Aid packet and my sugar are substances that can be dissolved, but we also need a solvent. Okay, so I'm going to go over to solvent here and put our dissolving medium. Okay, what's dissolving? Now, when I'm looking at solute versus solvent, to really distinguish between these two, the solvent is going to be the one that's more prevalent. So I'm going to have more water than Kool-Aid and sugar if I'm making a Kool-Aid solution, and water is my solvent and Kool-Aid and sugar are my solutes. That's going to be the more prevalent one. Is going to be considered the solvent, and the less prevalent one will be considered the solute. Okay, so now we're using another word in here, dissolving. What is dissolving if I have the solute and the solvent? I want you to think of this as a very physical process. And in dissolving, we have a solvent that is breaking apart. It breaks apart solute. Okay, we're breaking apart sugar molecules that were crystallized together. We're breaking apart particles, and we're taking those solute particles and we're uniformly distributing them. Particles. So in solvation, dissolving means we're breaking apart solute particles and we're actually moving them around. And there we go, that's a solution. So if you want to think about our little solute, I throw some Kool-Aid in my water, and this is a very physical process. After some amount of time, those water molecules will latch, or whatever my solvent will be, and they will physically break apart and uniformly distribute those particles and make a solution. And there's our solution that is the same throughout. Okay, so when I look at a solution, the next thing I want to talk about is we're going to take some measurements here. So I can quantify how much solute dissolves, and we call that solubility. Okay, solubility is a measure of, so this is a measure of how much, and when I say how much, I mean we're talking about a number and unit. Some examples that we're going to talk about are molarity or molality. Molarity and molality are two different ways that we can quantify the amount of solute that is dissolved in a solvent. So the measure of how much solute dissolves into a solvent at the given conditions. I say at given conditions because maybe from experience you would know that you could probably dissolve more sugar and Kool-Aid into some Kool-Aid if the water was hot, not that you want it hot. But it depends really upon the temperature and pressure how much you could dissolve at a given time. So a measure of how much is dissolved at given conditions to form saturated solution. So solubility is a measure very specifically of how much could be dissolved in a saturated solution. So it's very specific and it's tied into saturated. That's why I underline it. So just kind of as a refresh, two different types of solutions we can have are saturated, unsaturated, and then supersaturated. So if I'm kind of recalling, and I'm sure you've seen these before in some other classes, in a saturated solution, as much as possible, no more solute can be added. Okay, no more solute can be added. So it's kind of at the maximum possible that it can hold. Now this doesn't necessarily mean that there's a lot of solute in there, because some solutes will hardly dissolve at all to form a saturated solution. It just means that if you put any more in, it will not dissolve, it will fall out of solution. So saturated means we cannot add any more, even though it doesn't necessarily mean that there's a lot there. Okay, and we'll have to talk more about that as we go. Unsaturated means that we can add more solute. More solute can be added and will dissolve. Okay, so there's probably not a whole lot dissolved in there. There's still room for some. And then supersaturated, basically this only happens if we can mess with the conditions so that we can somehow put more solute in than would normally be possible for some set conditions. So how we might do this is we might dissolve a lot of solute into a solution, really heat up the temperature so it really gets dissolved, and then as it cools over time back to its a lower temperature, those particles that were dissolved may actually stay in solution, and it might become what's called supersaturated, where there's more than normally possible. Alright, so solubility is a measure of how much solute can dissolve into a solution, and we're going to talk about the two different ways that we can measure solubility, molarity or molality. These are two different ways in the next couple of days, and I hope that this was helpful.